So we're on to our last factoring pattern of the unit. It's called factoring ax squared plus bx plus c. Based on what we've done so far, you can probably imagine what that means. But before I even go to factoring, I want to return to multiplying binomials using FOIL. We know that to FOIL, I multiply the first together, and that gives me 2x squared. When I multiply the outer and the inner together, that gives me 7x. When I multiply the last, I get plus 3. So I know that this term times this term equals that term, and therefore I should be able to factor this trinomial. Using what we've done in the past, we would draw our parentheses, we would put in our variables, and most kids can see that if I've got 2x squared, that means that one of these has to be 2x and one has to be x. This sign here tells me they're both the same. This sign here tells me they're both positive. Now in all of the ones we've done up to this point, or almost all of the ones we've done, we would be looking for numbers that multiply to 3 and add to 7. However, it's pretty clear that there is no such thing that multiplies to 3 and adds to 7. Yet we know that this has two factors. The question is, why isn't this true anymore? How come they don't multiply to 3 and add to 7? And the answer is this. The coefficient of the quadratic term, hence the ax squared plus bx. What we see if we look back to our initial problem is that our 3 was multiplied by 2, making it 6x instead of just 3x, as it would have been had I been multiplying x plus 1 times x plus 3. That's what we've been doing all this time. The outer and the inner add up because these coefficients have always been 1, meaning that 3 is multiplied by 1, 1 is multiplied by 1, so I just add 3 and 1. As soon as I introduce a coefficient to the quadratic term, all of that goes out the window, and I need to guess and check. I'm not going to randomly guess and check. I'm going to check numbers that multiply. The first terms have to multiply to give me this, and we were able to do that pretty intuitively. And I have to also choose numbers that add up to, multiply to 3. So I could make a guess of putting this at 3 and 1. I already know that the first and the last multiply. I know that this works and this works. So what I have to check is the O and the I. This part gives me 3x, and this gives me 2x. Do these add up to 7? No, they don't. So my guess was 2x plus 3 times x plus 1. That was the guess. It didn't work because the O and the I don't work out. So I go back to the drawing board. I'll draw my parentheses. I'll put in my variables. I'll put in my signs. And since 3 is prime, and putting 3 here and 1 here didn't work, I'm going to switch those. And now I have, and we already knew that this was the answer because we multiplied it to begin with. So 2x plus 1, so this gives me 6x. This gives me 1x, and they do add up to 7x. So I'm going to give some steps. These can be frustrating at first. You do get better at them as you go. So let's try another one. Those look kind of hard. Let's try 3x squared plus 7x plus 2. Okay, so the first thing I want to do is draw my parentheses. I'm going to put in my variables. It's 3x and x. This tells me they're the same. This tells me they're both positive. So it's plus and plus. So I've chosen numbers whose first terms multiply to this. Now I need to choose what last terms would multiply to 2. Well, there are only two things that multiply to 2. So they could be 2 and 1 or 1 and 2. So we've made our guess, and now we just check the outer and the inner. This is 3x. This is 2x. They add up to 5x. Therefore, this is not right. I'm going to do another guess now, because it's really actually called guess, check, and revise. Excuse me. That's the one we already did. This time, I'm going to do the same thing. I'm going to draw my parentheses, put in my signs and my variables. I already know that putting the 2 within this set of parentheses didn't work, so now I'm going to put the 1 here and the 2 there. When I check it, I get 1x and 6x. That does, in fact, add up to 7x. So that's the check. The first thing you do is choose terms whose first products, let's see, that's probably not the easiest way to say it. What you want to do is you want to choose terms that work for the first, and the third. So I'm going to say whose products equal the first and third terms. This, in the FOIL, is the F and the L of FOIL. And now you need to guess. So that's your check. This is your guess. And then you just need to check the O and the I. You don't have to check the whole thing. You've designed the first and the last. You need to check the O and the I, like we did here. That's what that means. It's more complicated when C is negative. So let's try, and it's also more complicated when everything isn't prime. So let's try 2x squared plus 7x minus 9. Okay, so this time we're going to draw our parentheses, put in our variables. This time we know that one of the signs is positive and one of the signs is negative, because that tells us that the signs are different. So automatically, we're in a more difficult situation. We also know that 9 is not prime. So these two numbers could be 3, or they could be 1 and 9. I would guess, since this number is 7, they're probably not 1 and 9. They're probably going to be 3 and 3. So let's check our guess. This gives us 3x, and this gives us negative 6x. Okay. So that actually is clearly not right, because it's not negative 3. Perhaps I was wrong. Let's try another guess. So we've done a guess. We've checked it. We still know it's going to be 2x and x. We know it's going to be plus and minus. And we know it could now, it's not 3 and 3, so it must be 1 and 9. Let's check this. There's positive 1 and negative 18x. Well, that still doesn't equal 7x, so that's not right. Let's try 2x, actually, I'm going to try 2x minus 9 and x plus 1. I've got negative 9 and positive 2. That equals negative 7x. Oh, I'm almost right. If I get everything right except the sign, what that means is all I have to do is do the same solution, same factors, only switch the signs. So I'm going to make that plus 9 and minus 1. This is positive 9x, negative 2x equals 7x. This is the check. This is the solution. Let's try it. let's say 14x squared minus 17x minus 17x plus 5. Okay, the signs are going to be the same because of this. They're both going to be negative. It could be 1x and 14x or 2x and 7x. I'm going to guess. Sometimes your gut is right. Sometimes it's not. And then the two things it could be are 5 and 1 because 5 is prime, so its only factors are 5 and 1. This gives me negative 35 and negative 2. Clearly that's negative 37. That is not right. So I'm going to try 2x minus 1 and 7x minus 2. This gives me negative 7x. What's going on? And this is negative 4x, so that's negative 11x. And, oh, what am I saying? I'm sorry, this is supposed to be a 5. Because we are looking for numbers that multiply to 5. So let's erase this and say, this is negative 7x, this is negative 10x, that's negative 17x, and that's right. So you choose your guesses based on this, and then you check based on the outer and the inner, the O and the I. I wrote O and L, even though okay, so F and L here, and O and I here. One other thing I do want to show you, and this might not stick because it might not make any sense, but if I'm looking to factor, let's see if I can see a good example. Something this tough is probably not anything that, well, you might have to do something this hard tonight, but perhaps not. What makes this difficult is that this is a negative sign, making more options, and 12 has a lot of factors. But for now, let's just say we've got our signs. It's 2x and x. We know they're going to be different. And let's just pick 4 and 3 as our numbers. Well, right off the bat, I can tell that this one isn't right, because if it has a common factor here, it could have been factored out of the first step. So I guess that's my only lesson, is just realize that you're never going to have a factor that has a common factor within it. Mostly with these things, though, you just need to use your common sense and try. Remember, you're picking your guesses based on F and L, and you're checking them based on O and I.